Hello friends. Last time we have seen the theory relating to force analysis of helical gears. We saw how three components of a force acting on gear tooth can be determined using various parameters relating to a helical gear. Now we are going to apply that theory to a numerical example where actual numbers are given. Now look at this example. A pair of helical pinion and gear have 18 teeth and 40 teeth respectively. The pair transmits power from a motor rated 22 kilowatt running at 1440 rpm. The helix angle is 23 degrees and the normal module is 6 mm. Determine the components of tooth forces. Note: assume suitable data if necessary. Now think if there is any data which is missing here while we proceed. Now when we start solving this, remember, there are broadly two parts of the solution. First part is where we deal with the geometry and parameters of the helical gear so that we have the raw material ready for actually determining the components of forces. And the second part of the solution will be to actually determine the components of forces. So we summarize the data as a first thing. Power P equal to 22 kilowatts, capital N 1440 rpm, number of teeth on pinion and gear 18 and 40 respectively. Mn, which we use for denoting normal module, is 6 mm. Alpha is 20 degrees. Sorry, there's a typo here. It should be 23 degrees. Alpha helix angle is 23 degrees. Now the data which is missing here is pressure angle. So we will assume 20 degrees. Calculate transverse module so that PCD can be determined. Now we are recalling the steps. Now step 1 and 2 will be relating to geometry. First, determine the transverse module, because in case of a helical gear, if you want to determine PCD, first you should know the transverse module. So first determine the transverse module, and then next step is to determine the pitch circle radius, which will be nothing but PCD upon 2. And then using the pitch circle radius, we can determine tangential force. But before that, we need to determine torque. Once we know the torque and pitch circle radius, we can determine the tangential force and then axial force and radial force. Steps 1 and 2. Step 1. Transverse module MT is Mn, the normal module upon cos alpha. So it is 6 upon cos 23 degrees, which is, we calculate and we arrive at 6.518 mm. Step 2. Pitch circle radius is transverse module into number of teeth on pinion upon 2. Now the numerator is actually pitch circle diameter, PCD, and we divide by 2 so that we can arrive at PCR. So substituting the above values, we get 58.662 mm. Third step, to determine the torque. Now recall that power transmitted is 2 pi nt upon 60, so which implies torque equal to 60 into P upon 2 pi n. Now substituting power equal to 22,000 watts, n as 1440 rpm, we get torque as 145.9 Newton meter. Now we are ready to actually determine the components of forces. Tangential force Ft is torque upon pitch circle radius, because it is this which is actually responsible for transmitting torque. So when you substitute the value for torque and PCR, which we have calculated in previous steps, you arrive at 2.487 kilonewton. Next step, axial force is Ft, tangential force Ft into tan alpha. So using these two values and alpha as 23 degrees, we arrive at 1.056 kilonewton. Radial force is Ft into tan phi n upon cos alpha. This phi n is the normal pressure angle, which is nothing but 20 degrees that we have assumed, because currently that is the commonly used value for normal pressure angle in the industry. substituting Ft from 2.487, phi n as 20 degrees and alpha as 23 degrees, we get radial force is 2.875 kilonewtons. So that is how you calculate the three components of forces. So again, I will repeat one important aspect here. There are broadly two steps of the solution. In the first step, using the parameters of the gear, you determine first the transverse module, then you determine pitch circle radius, you determine torque, and then you are actually ready to determine the components of forces. So this last slide which you can see on the screen right now is the final step. Thank you.